Okay, Algebra 3.5, write ratios and proportions. This begins on page 162 in your textbook. Okay, so a ratio. Think, what comes to mind when you think of the word ratio? And I hope you have an image of some kind. And yes, a ratio is comparing two numbers. And it involves which operation? Division. Good. So there are three ways we can write ratios, if you recall. And so one, of course, is going to look like a fraction. And then we also have the ability to put a ratio in words, A to B. We can use a colon, A to B. And, of course, your fraction, which you're so familiar with. Let's see if you can write a ratio. Derek and his brother decide to combine their CD collections. Derek has 44 CDs, and his brother has 52 CDs. Find the specified ratio. So if you could jot that sentence down, you might need to pause the video, jot the sentence down so that you have something to study from, and see if you can answer the two questions. Question number one. The number of Derek's CDs to the number of his brother's CDs. So when we think about the number of Derek's CDs to the number of his brothers, pause the video, put down what your best ratio is to describe that relationship. Okay, and when you come back, let's see. Derek's CDs. Derek has 44 CDs, so that would be our numerator. And his brother's CDs, his brother has 52 CDs. Very good. Okay, so if you started with that, you started in the right place. But what can we do with a ratio that is 44 to 52? Yep, we can reduce it. So what is the GCF? What's the greatest common factor of 44 and 52? I hope you're thinking 4. If you thought 2, that's true. 2 can go into both of these numbers. When you divide by 2, you would end up with 22 over 26, right? So which could be divided by 2 again. So when you divide both of these by 4, we end up with 11 over, so you can line this up. 4 goes into the 50 once, 4 goes into 12 3 times, so 11 over 13. We can see that these numbers are relatively prime, 11 and 13. They have no factor in common other than 1, so you have a reduced ratio. So when you are asked to place a scenario like this into a ratio, make sure that you reduce it to its simplest form. Okay, and the second question, the number of Derek's CDs to the number of CDs in the entire collection. Okay, so stop the video and see what you could do. Okay, so we have 44 CDs in Derek's collection, and what do we have in the entire collection? We could write this as 44 plus his brother's 52, and when we do, we get 96 CDs. So we now have a ratio of 44 to 96, which of course needs to be reduced. So pause the video and see if you can reduce that. And when you come back, we have again 11 over, how many times does 4 go into 96? 24 times. 4 goes into 9 twice, with 16 left. 11 over 24. We can see 24 is a composite number, but 24 and 11 have no factor in common except for 1. So once again, we can say that they are relatively prime. So we have a reduced fraction. Awesome. Okay, let's go on and see how we can address a proportion. What does a ratio have in common with a proportion? Hopefully you have an image in your mind of a proportion being an equation that states two ratios are equal. Awesome. Okay, so let's talk about how we might solve a proportion. There are two popular strategies for solving proportions. So let's set up the same proportion, and we'll call the first version A and the second version B. So when you look at this proportion, what comes to mind with solving? One thing that might come to mind is we could use our, what does this remind you of here? Yep, our cross products property. Let me jot that down under here. cross products property. We're going to spend a lot of time tomorrow and the next day looking at cross products property. So you know that you would bring the denominator, you would multiply the opposite numerator by the opposite denominator. So in this case, we would end up with, let me see if I can do this without using the whiteboard. We would end up with 17 times 12. Oops, that's a little too big. Let me shrink that down a little bit. 17 times 12 equals 3h. Okay, and that's a little bit small. Let me blow that up. There we go. Okay, and so when we multiply 17 times 12, we end up with 10 times 12, which is 120, plus 7 times 12, which is 84, and so we end up with 204. 204 equals 3h. 204 equals 3h. And so go ahead and use your inverse operation to solve, and when you do, you find that, yes, 68 equals h. Very good. Okay, so what's another way we could solve this proportion without using cross products property? Well, what would we have to do to get from 3 to 12? And if you said multiply by 4, good job. So if we can multiply the numerator by 4 to get to the other numerator, we would do the same with the denominator. And guess what? 17 times 4 equals 68, the very number that we had using our cross products property. And what do we call this? When we multiply by the same factor, both the numerator and denominator, to get to the new fraction? Yeah, in our class we call that blowing up fractions. So blowing up fractions, I think, is the fastest way to find an equivalent fraction, and but either method will give you the answer, and so you may use whichever method you prefer. Let's try it with a couple of samples without even writing these down. When we look at question number 3, 7 times what is 35? Good. So 4 times 5 is 20. Good. See if you can find the answer to number 4. 9 over 2 equals m over 12. So m equals 54. Good. 2 times 6 is 12, so 9 times 6 is 54. And here's another one. Z equals, if 9 times 6 is 54, 5 times 6 is 30. Good. Z equals 30. So try to use your blowing up fractions as much as possible today, because we will get into cross products more tomorrow. And, oh, here's one other question before you start your assignment. When you have this ratio, it doesn't look quite as easy to blow up. So what could you do to make this a simpler ratio? And I hope you have said already you could simplify this fraction, couldn't you? Here's 4/12 equals 1/3. And when we have 1/3, we can see that 3 times 10 is 30, so x equals 10. Awesome. Very good. So have fun now working on your oh gosh, one other thing, sorry. If you can jot down this sample. A backpacker hikes 5.5 miles in 2 hours. If the hiking rate remains the same, how far will the backpacker hike in 7 hours? You got to write that little question down. And there are probably 8 ways you could set this up to answer this question. So do your best job in setting up a proportion to answer this question. And let's see what you came up with. Pause the video and see what you can do. Okay, if you're back, let's see. The most common proportion that was mentioned in class today when you weren't in class was 5.5 over 2. So the backpacker can hike 5.5 miles in 2 hours. So we have some unknown number of miles in 7 hours. So if this is the proportion you came up with, this was the number one proportion that students most often come up with. Another way to write this would be to write it as in 2 hours, the hiker went 5.5 miles. So, in 7 hours, how far did the hiker go? It's basically the first proportion, but flipped upside down, the reciprocal of the first proportion. So this is called the reciprocal property of equality. If I have a proportion and I flip both ratios, the proportion maintains equality, which is kind of awesome. Another way we could have written this is 5.5 is the number of miles that the hiker went in 2 hours. So, how many miles x would a hiker go in 7 miles? You can see there's a lot of ways to set up this proportion and to answer the question correctly. So we're not even going to worry about the answer. We're just talking about setting things up. Okay, you're now ready to begin your assignment for today. Have fun!